Hello guys, welcome once again to the channel. My name is Amos from Acoustics, and in today's video I'd like to share with you some few tips on how to treat a large space acoustics. And by the large space I mean a church, to be specific, because large space we also have things like auditoriums. We have these large performance venues that accommodate a lot of people and hosting a lot of events. So in today's video I'd like to narrow it down and just talk about church specifically, because there's the rising issue of guys not being able to hear the sermon clearly. And that is due to the reflection that bounce off the walls and the ceiling, and causing all this kind of distortion and making things very hard to understand in this kind of environment. So today I want to share with you a few tips on how to go about acoustic treatment for large spaces and a church, to be specific. So if you look at my previous video, I normally focus on small studio acoustics. And in today's video, I want just to differentiate on the approach that we need to take when designing acoustics for the church and acoustics for the small studio. So this is where the difference lies. If you look at small studios, in most cases, we deal with the two problems. The number one problems we deal with in small home studios or small rooms generally is normally room modes. And also we deal with the reflections or reverberation, in other words. And this is due to the dimensions of this kind of small enclosed spaces. So if you have a smaller room and the dimensions of that room will kind of correspond to certain wavelength of specific frequencies, then these frequencies will tend to cause distortion and what we call standing waves, and that is how we end up with the room modes in frequencies below crossover point, which is Schroeder. Schroeder is the crossover point at which either the room start to resonate or start to be reflective. So in most small rooms, the Schroeder frequency is normally around 200 hertz, between 200 to 50 hertz, and that means above that range the room will start to be reflective, or a lot of signals that are in the room will be reflected energy or ray energy, and signals or frequencies below the Schroeder range or Schroeder point will be resonance. So it means if you have frequencies below 200 hertz, they will tend to resonate in this kind of smaller rooms. So the difference on the other side with the large room like a church is that in large spaces we have very big, large volume, and the dimensions are longer compared to the smaller rooms. So what that means is that in larger rooms we have enough dimensions to accommodate the low frequency wavelengths. And if we look at the shorter frequency in simpler term for these large rooms, it shifts. It goes sometimes it goes below 20 hertz. What that means is that we have less modal issue to deal with and more of reflection based issues to deal with. So how do we treat a church and make it sound better? So just like in a small studio, we have what we call first order reflection points, or first reflection points, second reflection points, and all that kind of a geometrical prediction. And in a small studio, normally we can use mirrors on the side walls to kind of locate first and second order reflection points, and the same applies to churches. The only difference with churches is that a lot of churches are not designed with the acoustic provision. So that means you find some churches are really hard to treat because almost 80% of the side walls is covered with the large windows and glasses, and the ceiling is could be gypsum or acoustic ceiling, of which most of them are not very effective. Very few of those acoustic ceilings actually work. So how we treat large spaces is that we also need to map out first reflection point, second reflection point, and place acoustic panels strategically in those locations, and also ensure we have good coverage to be able to tame this excess reverb that is in this kind of rooms. So we normally focus on 125 or roughly 100 hertz, all the way around to 4 or 5 kilohertz and above, because we want to mostly focus on reflection based issues. So the question is, which kind of panels do we need to install in these kind of spaces to make some audible difference? Just like in small studio acoustics, we have broadband absorption, we have bass trapping for the low frequency issues. So in large spaces, we don't have problem with the low frequency issues. We have a lot of problems with the reverberation or reflections of the walls, ceiling, and the floors. And that is why we need to choose appropriate kind of panels which will be able to kind of bring things under control. So I'm going to use a case study of a church. It's not actually a church, I would call it is a multi-purpose hall. It's used as a church, and also it's used for other events that we were tasked with treating and bringing the reverb time down because the client was not happy during the services. So if there's a church, a lot of congregants were not able to hear the sermon clearly because this room, as you can see from the diagrams here, is all concrete and the floor is tiled. the side walls. Not so much windows are here, but it's all concrete. Even the ceiling up is concrete, so it has excessive reverberation. And by that, the measurement that we took with the impulse sound was around 3.8 seconds before treatment. So when you look at auditoriums or these other large spaces that are designed for music specifically, there are certain RT60 or reverb time that are recommended, because when you come to music, certain genre of music will require slightly longer RT60 or reverb time. It makes them sound a bit richer and more natural. But when we talk about speech, then we need a very short reverb time. We need shorter decay time to make things a bit audible. So in this case that we want to talk about of this multipurpose hall, the issue was the speech. So we wanted to make the speech a bit clearer, and also some parts of instruments a bit clearer. By that. Controlling reverberation from 500 hertz and above. So due to budget constraint also, you understand that if we make thicker panels that will go probably to around 125 hertz, then we will need them to be thick enough, and that also boosts the overall cost of the project. So the idea was to first of all focus on the issue at hand, which was cutting down the reverb time and making speech a bit clear. So our main focus was to get absorption materials, or the core material that will be used in these panels, that had the highest possible NRC based on the absorption per frequency as shown by the manufacturer. So we try to look out for the most affordable and available options, and we ended with the mineral wool of 48 kilograms per cubic meter, and from the manufacturers the rating was 0.8. That was decent enough to give us some proper absorption from around 500 hertz all the way to 4 kilohertz and above. So this is how we approached the project. We had to map out first reflection points, and you can see the stage area here. This area had so much reverberation, and also the upper deck. If you look at this space here, just like most of other churches, the design is almost similar. We have the ground floor, we have the stage area, and then we have this upper deck with the kind of stairs where congregants can sit on. So these two areas had excessive reverb. That is the stage area. You can see the stage area here, and then also the upper deck also had excessive reverb. The guys who are just below the deck, below the upper floor, are kind of shielded from the main ceiling reflections. So the RT60 that we took down there was slightly shorter compared to the stage area and the upper deck. So these were the areas that we needed to focus on and install the panels correctly, and also get a good coverage to be able to bring the whole reverberation down. So after treating this room, as you can see here, we had around 60% coverage on the ceiling, and then the front area we also had around 50% coverage with these mineral wool panels. These panels were 4x4, most of them, because we wanted to cover a larger surface area for the at the shortest time possible, without making too many small panels, maybe 2x4s. It will be that would be almost twice the number of panels that we installed here. So we wanted to cut down the time, or the lead time, and also installation time, and that's why we went with these very large panels, 4x4 feet, and all of them were 2.5 inches. With the mineral wool core with 0.8 NRC, and the fabric that we used here, as usual, normally use a polyester fabric because of the fire properties, and also is very porous, so the absorption that were offered by these panels were massive. So the reverb time was reduced from 3.8 seconds to 1.8 seconds, which was a great improvement, especially from 500 hertz and above, because now at least the client was happy with the way the whole sounded. Even if they conducted a sermon in this kind of environment, it was very easy to at least now understand the words clearly, because we had to cut down the decay time from 500 hertz and above. So in cases where a broadband absorption is needed because of the instrumentation, sometimes you may need to absorb more towards the lower frequency, then thicker panels will be required at that stage. But for this is how we went about it, and managed to bring the reverb time down to 1.8 seconds, which was a good job. So you can see how the panels were installed here. These were the most offending surface areas. So that is how you treat a large space like this one. It's just a basic kind of treatment. It's not very complicated. We just need to get enough surface area to treat, and also use the appropriate materials for this kind of work. So hope this was helpful, guys. Thank you guys for watching. If you like the information in this channel, you can like, share, and also subscribe.